In our final lesson for this particular unit, we're going to be talking about multi-stage finance problems. So combining some formulas together as we talk through real life situations that can happen with respect to finances. I also included, so while the picture is a copy paste, in Blackboard I do have the hyperlinks. You can see this in a larger format or blown up, kind of a flow chart for how you determine which formula to use and when. So the key is up in the top right, where M represents the number of intervals per year, T represents the number of years, R is the interest rate, N is the total number of intervals, which is the number of intervals per year times how many years, and then the interval interest rate is the rate divided by the number of intervals per year. So keep that in mind as we go forward. You might want to refer back to this chart from time to time. It's just a great place to kind of put all of the thoughts together for this particular unit. Example 1, suppose you deposited $15,000 into a bank account offering a special 6% APR. After 1 year, they lower the APR to 4%. Then 2 years after that, lower it again to 2.5%. If the account compounds monthly, what will your account balance be 6 years after the initial deposit? So in this particular problem, I'm thinking of 3 separate instances where we're going to start off with the $15,000 initially invested for 1 year. And in that 1 year, we are at 6%. I'm going to withdraw that money and put it into a new account, deposit into a new account, and this new account is going to be for 2 years at 4%. Again, I'm going to withdraw that money and put it into a new account for 3 years at 2.5%. So after then 6 total years, we'll be able to find out how much total money we have. It's telling us that we're compounding monthly. So this tells me that we're going to use the compound interest formula. So I'm going to start off with the first year. The amount in our account will be the amount we initially invested times 1 plus the interest rate divided by how often we're compounding, which is monthly, to the power of 12 monthly payments for 1 year. And the amount then, I'll let you put that into your calculator. We will have, oops, don't need double signs there, $15,925.17. This, of course, I'm going to withdraw from this new account, figuratively speaking, and put this $15,000 in the 2-year account at 4%. So I'll start off with $15,925.17. Apply that to the compound interest now at 4%, compounded monthly, to the power of compounded monthly times 2 years. And this will give me $17,249.24. Of course, I'm going to do the same thing as above. I'm going to withdraw this and put it into a account for 3 years at 2.5%. So I'll have $17,249.24 times 1 plus our new interest rate, 0.25, divided by 12 payments per year for 3 years. Again, I'll let you put that into your calculator. So after 6 years, we will have $18,591.23. in 6 years. As we go from one account, change interest rates, more time lapses, change interest rates, and then the final time that's lapsing. Jenny plans to retire at age 65 and estimates she will need $48,000 a year in retirement for 30 years. To save for retirement, she plans to put money every month into her 401k plan at work. If Jenny is currently 25, how much will she need to save each month to meet her retirement goal, assuming her retirement accounts earn an average of 7% per year? So I'm thinking this as twofold: the amount of money that she's going to save until she's 65, and then the amount of money from 65 to 95, the 30 years for retirement. So she's only planning to apparently live till 95 years old. So let's see what this looks like. So at the beginning, she's at $0. And she says that she is currently 25. So at 25 years old, she's got $0 saved up in her retirement. So she's going to save for 40 years. And she's going to accrue 7% during that time, it says, across the whole thing. So in 40 years, she will then be 65, the age she wants to retire. Well, we don't know how much money she will have. But then she's going to start drawing on her retirement for 30 years. She says she needs $48,000 per year, which would then be $4,000 per month. And she's still going to earn 7% on her money that's left as she's withdrawing over those 30 years. She'll then be 95 years old. And she will have depleted her money. So what is that magic number she needs to earn? We know much more information on the second half. So we're going to start here because it gives us more information, kind of build backwards. I know that I'm going to build to $0. I know how much I need or want, for how long I want that money to be, and I know an interest rate. That'll give me the amount of money which I started with before I started depleting. So this is going to be a payout annuity. Formula that we're going to use. So the amount that we're going to have in that account is going to equal the monthly payment that we're giving ourselves. 1 minus 1 plus 7% divided by 12 months to the power of 30 years, negative 30 years, times how many payments? All divided by 7% over 12 months. And again, I'm going to let you use your calculator to verify, but that gives us $601,230.27. This is the amount of money that she needs to have in her account by the time that she retires at 65 in order to withdraw $4,000 per month to live on until she reaches the age of 95. Well, now that we know this, we're going to be able to determine how much money she should put in her savings, a 401k every month. So then we'll use a savings annuity in order to find the payment that we need. So a savings annuity where our payment is at the end of every period. The amount we want to reach is $601,230.27 is equal to our payment times 1 plus our interest rate divided by how often we're compounding this to the power of 40 years times 12 months, because that's the amount that we're saving this till. Minus 1 all over. And again, our goal is to find the amount of payments. So I could multiply by the reciprocal, or excuse me, I could simply just multiply both sides by 0.07 times 12 and do the same here, and then divide by everything that's in my bracket. So I'll let you algebraically solve for that, but sometimes I think the hardest part of these is getting the correct formula in order to solve for them. You'll end up finding that your payment, once you solve for P, is $229.06 per month that she should be placing into her 401k. Our third problem, Eula got a new job. She had $70,000 in a 401k at her old job that she rolled over into an IRA. She plans to continue contributing $5,000 a year into her IRA. If her account earns 6% compounded annually, how much will she have in her IRA in 10 years? The way I'm looking at this is the amount that she's rolled over and the amount that she's starting from scratch with. Both of them are working simultaneously together. So I would think of this as putting my original rolled over value into an account that is compounded annually for 10 years at 6%. How much money would this be? I'm also thinking about starting from scratch. I'm depositing $5,000 per year, still again earning 6%, and doing this for 10 years. How much money will we get? And then, of course, combining the two portions together. Because I'm only going to be getting a annuity payment, savings annuity payment that I'm placing in there with the right-hand side. The $70,000 is just rolled over, and it's just going to continue earning that 6%. So I'm going to start with the left-hand side. It's just the compound interest for our first part. Or the amount that we will have in that account is the $70,000 that we put in times 1 plus the interest of 6%. We're compounding one time per year. So one time for 10 years. And again, I'll let you use your calculator to verify, but this does give us $125,359.34. Now, the second part is not a compound interest. The second part is a savings annuity, because you're continually putting money into an account that you're earning interest on. So the second part of our account is a savings annuity. And the amount we will earn on this account is $5,000 times the quantity. Since we're putting our payment in at the end of every year, we'll have 1 plus 6% divided by 1 time per year to the power of 10 years times 1 time per year minus 1 over 6% divided by 1 time per year. And then utilizing your calculator, you can do that portion. The amount that we should get out of this portion is $65,903.97. Thus, we can add these two portions together. So at the end of 10 years, after she rolled over that $70,000, still earning some interest on that, she will have $191,263.31. 5 years ago, a couple purchased a home for $260,000, making a 20% down payment and financing the rest with a 30-year adjustable rate mortgage fixed at 3% for the first 5 years. Now that the fixed rate period is up, the couple is facing a higher adjustable rate. They now plan to refinance into a fixed rate 30-year mortgage at 4%. What will their new monthly payment be? Assume there are no costs associated with refinance, which is unlikely because there's usually costs associated with refinancing. But for the sake of this problem, we'll see no. We first need to know how much was financed, right? We had a 20% down payment. So how much of this loan was actually financed? So I can take 260,000, times 20%. And our down payment was $52,000. That means that if I were to take 260,000 minus my down payment, we have 208,000 was financed. Now we need to find the amount of payments we're going to use to pay down that loan. So we'll use the loan amortization formula to help us do that portion. So I know that I have $208,000 financed. I don't know what my payments are, but I'm going to find that. So 1 minus 1 plus my interest rate of 3%, 12 payments per year to the power of negative 12 payments times 30 years divided by 3% over 12 months. I'm going to let you solve for P independently. That's just some algebra. The payment then is $876.94 per month. Well, now that we know what our payment is, we should be able to find the remaining balance after we've made payments for 5 years. So to find that remaining balance, with our payment known, we can use the same formula just with 25 years instead of 30 and utilizing our payment that we have of $876.94 times the quantity 1 minus 1 plus 3% over 12 to the power of negative 12 times 25 years, because that's what we're interested in, how much is left on our loan. And again, I'm going to let you use your calculator to do this. So the remaining balance is $184,926. This is the amount that we have to refinance at the new interest rate of 4% so we can find the new payment. So using the same formula above with my new remaining balance, $184,926 is equal to our new payment amount with our new interest of 4% divided by 12. Our loan is still refinanced for 30 years, all over 4% divided by 12 payments per year. Our new payment then is $882.87. Just some additional thoughts before we leave this particular page. I wanted to just kind of follow through with some ideas here. So the first 5 years, we made $876.94 payments. We did that over 12 months for 5 years. So we ended up paying $52,616.40. Our balance, our principal balance, reduced by the $208,000 that we financed originally, minus that leftovers $184,926 that remained after 5 years. So $23,074. Thus, if I were to take $52,616.40 and subtract the $23,074, this would give me $29,542.90 that I paid in interest. Here's my interest payment. Here's the amount to principal. And this was the number of payments made. You could even find, doing the same idea, you can, with the new payment amount for 25 years at $882.87, determine how much of your money actually went to the interest, which is kind of significant in this problem. But that concludes all of this particular unit.